Hello everyone, my name is Shreyash Sparsh and in this video I am going to solve some short questions of chapter real number. So let's start. So let's start with our first question. Our first question is prove that n square plus n is divisible by 2 for any positive integer n. We know that positive number can be written in two forms 2m and 2m plus 1. So we will take n is equal to 2m and n is equal to 2m plus 1 in two cases. N square plus n is equal to the 2m square whole square plus 2m when we will take n is equal to 2m. Finally, it can be written as 2m into 2m plus 1. Now, n square plus n is equal to 2r where we have taken r is equal to m into 2m plus 1. It clearly shows that n square plus 1 is n is divisible by 2. Now, we will take a second case. N square plus n is equal to 2m plus 1 whole square plus 2m plus 1 where n is equal to 2m plus 1. Finally, it is 2 into 2m plus 1 into m plus 1 where we have taken 2m plus 1 and m plus 1 into m plus 1 as s. So it is finally is 2s. It clearly shows that n square plus n is divisible by 2. From both the cases, we can conclude that n square plus n is divisible by 2 for any positive integer n. So let's move to our second question. Here HCF is 116 and LCM is 1740 and one number is 580, find another. So before starting this question, I want all of you to know that the product of HCF and LCM is equal to product of number. Here I have taken those numbers as X and Y. So LCM into HCF is equal to X and into Y. 116 into 1740 is equal to 580 into Y. Y is clearly 348. So another number is 348. So let's move further now. So here we have to prove that root 5 is an irrational number. First, let us assume that root 5 is a rational number. If root 5 is a rational number, it can be written in form a by b, where a and b has no common factor other than 1 and b is not equal to 0. Root 5 is equal to a by b, root 5b is equal to a. Now we will square both the sides and it's 5b square is equal to a square. B square is equal to a square by 5. This clearly shows that 5 divides a square and it means that a is also divisible by 5. Now we will write a by 5 is equal to c. Thus a is equal to 5c. Now we will square both the sides and it will lead to a squared is equal to 25c squared. A square is equal to 25c squared. Now, we will put this value of a squared in last equation. Our last equation was a squared is equal to 5b squared. So 5b squared is equal to 25c squared. B square is equal to 5c square and it shows that b square is divisible by 5, which further means that b is divisible by 5. Uh, it contradicts the fact that both a and b have no other common factor than 1. So our assumption was wrong. Root 5 is not a rational number. It is an irrational number. So from in this way it is proved. In our next question, we have to prove that 66 by 180 is not a non-terminating and repeating decimal. We know that if any number's denominator is in form 2n into 5m, then it is a terminating decimal. Let's see what's the prime factorization of this fraction, denominator of this fraction. So 66 and 180 has 6 as HCF. So in the simplest form, it can be written as 11 by 30. The denominator 30 has 3 and 5 as its factors. Now 2, 3 and 5 are not equal to 2n into 5m, which clearly shows that 11 by 30 or 60 by 180 is a non-terminating and repeating decimal. So here is our question. Find a rational number between root 2 and root 7. Now we know that between root 2 and root 7 there exist many infinite numbers. So we have chosen a normal perfect square 6.25. Now we know that 6.25 is perfect square of 2.5. So 2.5 square uh, root under 2.5 square can be written as 2.5 square. 2.5. So root 2 is smaller than 2.5 and 2.5 is smaller than root 7. So 2.5 can be written as 25 by 10 and 25 by 10 in its simplest form is 5 by 2. So 5 by 2 is a rational number and it is between root 2 and root 7. In this way, we can find infinite numbers between root 2 and root 7. Hope you have liked this video and thanks a lot for watching. Thank you.